So for the last hour of this training, we'll go into the module 3. I'll just wrap up what we discussed about the module 2. I just want to reiterate again. The MISI principle, well, is really an ideal case. It's the most ideal situation where we can have something completely not overlap with one another. Right? It's mutually exclusive. They don't overlap at all. But collectively, they are still covering the whole scope. But really, in real life, a lot of the problem that we ever come across, not necessarily able to differentiate completely in that way. So the decisive factor, the last question that I showed here, really is what the research wants to look at. Right? What we want, the main factor, or in other words, the main key driver that we really want to look at. So for example, the case for the exercise that we will practicing here. If raising is the main key driver, then it should be on the second layer. Then the third layer obviously will going to be programming. So knowing which key driver that we want to focus on has a very big say on how we want to communicate our result. Okay. So the third module that we're going to go into is the result, the presentation, the communication of the result. Okay. So we look at the factor that influencing the choice of the presentation method, the chart that we should avoid to use during the communication of the result, and also the different chart types and also their appropriate usage. Okay. And then lastly, we'll go through a few charts that I managed to pick up from your work so far. Then we can go through each of them and see which one is a good result presentation as it is, and where we can improve further. So if I ask you, what decides the choice of the result presentation? What would you, if let's say you're going to plot a chart, any chart, what would be the decisive factor? Okay, we know the key driver is one. Okay, right? But other than that, what else would you think of? Or more specifically, how do you know what to plot?
Depends on what you want to show, like the values or pattern or composition.
Okay, so what we want to show, any other things? You can think.
Your audience interest.
Audience interest, yeah. So I will call that the output. Okay. But in a nutshell, two things only. The output that you want to show, or what the audience are interested in, and also the input they want to see that affect the output. And chart, like it or not, most of the chart that we're plotting, most of the time, is two-dimensional chart. Which means one axis will show the result, the output, the other always show the input. Very simple mathematical chart that we probably start the first time we plot any chart. y equal to mx plus c, let's say. Right? We have one input, we have one output. Okay. But as our exercise previously up until this point, because you are solving complex problem, so you have more than one input, that's for sure. And you definitely have more than one output as well. So knowing which input and output combination that you want to show will be the most important factor that will decide what type of chart you should use and how we want to show it. Okay. And then of course from there we need to know whether we want to show the trend, we want to show what we want to highlight, or what kind of insight we want to give to the audience. And of course, we say that it's a two-dimensional chart, okay? But sometimes we can actually have additional layer of information put inside that two-dimensional one. So really, we need to constantly ask ourselves, how many input and output that we want to show? Okay. Because it can be more than one. But more precisely, okay, before we go into which chart we should use, let's look at what we should avoid first, perhaps. Okay. And here I managed to find three. I would say these three definitely have to avoid. Okay. But anyone can tell why we should avoid this kind of problem.
Too many colors.
Too many colors.
Too complex.
Too complex. Okay. But both are correct. If I ask you the chart on the left, what can you understand out from it?
You mean the content?
Like if just in a glance, what kind of information you can grasp off from it? Apart from
There's one
Yes.
input and output. The total output and the output broken into smaller parts.
Okay. What I see is, okay, usually the horizontal axis is the input, right? The vertical axis will be the output. In this case, there are a few input they are comparing, and they're looking at one output. The only thing I can tell from here is from left to right, the input, the output result is decreasing. That's all. And that's pretty much the only thing that we can really tell from here. They try to show additional layer of information inside the ratio of them, but then it's way too messy. It's impossible to look at. How about this? Slightly better, not as bad as the first one. So if I just look at this, well, we don't have to even bother about what the axes are actually showing. Any
There's fluctuation.
fluctuation? Pretty much it, right? There's fluctuation. And that's the only thing obvious. I can only imagine this person try to show the relationship of each of these. These are basically additional key driver. It's another layer of the X, the input actually. They want to show the trend of it. Specifically, they are showing how they compare to one another. But I think it is, first, there is no clear trend. That's one thing, apart from the fluctuate a lot. Second, lack of focus. For someone who have no prior knowledge to this chart, look at it, we don't know where to focus. Because everything trying to catch our attention. So this is the exact kind of chart that we should always avoid. If let's say we really have to show in this way, at least at the very minimum, we should highlight the one key driver that we want the audience to focus on. At least to see. How about the one?
The one with very small percentage, they are not clear.
Exactly. Usually, when we want to show the proportion, the first thing that we thought of is to use pie chart, right? Because pie chart will be divided accordingly. But in this case, from at least from here to here, it looks more or less the same. Like we can't tell the difference between them. Then this slowly increase. At least we can tell this is largest among all, and this size smaller. But the almost like 80% of the pie chart is we can't really see anything. And not to mention that when we divide it according to so many slices, we ran out of color. A lot of color, like where is this? We can't tell it. So it's not a very effective communication after all. So that is the exact point that I want to make here. First, we always need to know what we want to show, like which insight they want to show someone. If let's say this pie chart here, the author actually want to highlight this slice, then the rest of it shouldn't be stand out so much. Rather, it should just that particular slice that grabs the audience attention. And here we see, okay, apart from their messy, they don't convey the result nicely. There are three very different charts. We have the bar chart, stack, of course. We have the line chart, we have the pie chart. Even though they're all showing the output for sure, and also the input. Even for the pie chart, there is input as well. But the information it tries to deliver is different. This one tries to show the proportion among one another. This one tries to show trend over whatever this key the key driver is. Okay. Hence, the types of chart really can vary a lot. So here I just simply grabbed a few from the standard plot you can get from Microsoft Excel because most softwares using Excel. Okay. So on the very far left here, there are, even just for the bar chart, I think there are more than 3 types you can actually choose. From the very top, just the side-by-side comparison bar chart. We have the stack, and then we have the 100% stack. Then we have, besides the vertical bar, we also have the horizontal bar. Same, we can side-by-side compare. We can stack them, we can plot them in 100%. So obviously, besides which type to choose, vertically there are variation in each of them as well. Other than bar chart, we also have line plot, we have scalar plot, and you probably see this as well, bubble plot. Even the size of the bubble can change. So it's almost like scatter plot, but now it carries one extra layer of information, one additional input or output. And we have area plot some more, right? Stack area plot, 100% area plot. And we also have fountain plot, all sort of different plot that we can actually get out from it. And this is just standard Excel plot. Not to mention that if any of you is using more advanced programming like Python, like the one from Microsoft, which is
Power.
Power. And also there's also another equivalent software, this kind of software. They can actually give you much more complex plot. And then of course we have the pie chart, we have the sunburst chart, we have the tree map as well. So among all this, how do we decide what to choose? It depends on the information that we want to show, for sure. But also there are a few rules of thumb that we can always follow. Between the bar chart, the horizontal bar chart, the horizontal bar chart, okay. Usually, someone will use it to show something with time related, which means from first bar to the second bar to the third bar, there is a element of time inside. 2 days ago, yesterday, today after tomorrow. It show the factor of time inside. Whereas for vertical bar chart, usually we show something without the factor of time. It can be any category. As long as it's not time related, then usually we use a horizontal bar chart. Anyone know why, when it comes to time, we choose the horizontal variable? Oh, sorry, here the horizontal means the variable, or the input, let's just say, or something that we are changing. So any thought why this, if the bar go this way, then from category 1 to 4 tend to be the time related?
Because it's progressing from left to right.
Exactly. It's almost like the progress bar when we watch video, right? You see, we always scroll left to right. It's a obviously it's like more like the tendency of majority. It's more convenient that way. Just like no one will make the time bar vertical. So mainly for that reason, it looks more natural. So likewise, when you plot vertically, of course, if you label it clearly, someone happened to read the axis, then of course they will know probably it's not time like the chart just now. Okay. But otherwise, if someone just saw a plot, first thing that most people come to mind, it will be time related. Just like the one earlier here. You see, show a trend line. We call it trend lines. Even without digesting what it actually means, it sort of like already tells, okay, it's trying to show the fluctuation over time. So horizontal, most of the time to show. And of course, if we want a more clear illustration of the trend from time to time, we can always put in line to connect. Even for the bar chart, let's say from here to here, sometimes people will show the line to connect it. If not, also for the line chart, it can be just a pointer, but sometimes if someone wants to show the trend, that we connect the line. So it's more clearly connected from one time to the other. Whereas for horizontal bar, the one that show different category, it is good to use it for comparing different categories, because even though when we look at something that goes from left to right, we associate with time. But I'm not sure if you know this. When you read, let's say I show a slide in front of you, what would be the first thing that you tend to look at? If I just randomly show a slide to you, like where would you start to read it from?
The shapes.
The shapes.
The middle section of the bar.
Middle section
Of the chart.
Actually, most people will start from the top left corner. Unless it's something really eye-catching right at the middle. Otherwise, it's just a very any graphic. Not sure why. It's a finding from I don't know what's it called. Most people will start from the far left top corner. And how do you think that will progress? Going sideways or going down?
For me, I'll look at the middle, which going down.
Middle and go down.
Diagonal.
Diagonal. A bit difficult to argue, but I suppose most people will go sideways. That's also why we write things from left to right. We don't write downward. Right? Probably you finish scanning that already, then you start to shift to other places. Right? If let's say you start from the middle, chances are behind you also go sideways a bit before you come down. It's just tendency to do that. So which means if we're showing, let's say, the stack chart, actually it's more natural to show it like this. Then the difference is very clearly shown. Whereas compared to this, can, but then you have to look at this guideline across there to look at the difference between. But if you look at here, then you come down, it's most. You can also argue that it's longer, so make it easier to look at, because the aspect ratio always horizontal, right? So in fact, that's another reason why screen usually is wider. Because that's how human eye will actually catch things. Sometimes even without us realizing. So that's the biggest difference between horizontal bar and vertical bar. As for you want to show the 100% stack or the actual proportion in the magnitude, it's really up to what you want to show. For this actual stack only, not 100%, main thing is you want to show their combined magnitude as well. Because if you show everything in 100, you don't see the magnitude. Of course, you can label at the side, but then someone take additional time to digest it. And that is one thing that someone want to avoid when plotting an HR, which is you want someone to look at it, they get the information you want to tell them right away, without even thinking. That's the aim always to go for. Scattered plot. In your study, do you use scattered plot often? What's the difference between scattered plot and line plot? If you connect line here, does it make it line? It does. Actually, not really. Because you see, the line plot here, by default, this is by default. I didn't key in any actual data. For line plot, it shows category. So if your category happened to be 2 days ago, yesterday, today, the day after tomorrow, then yes, it's the same with scattered plot, because the interval between them is the same. But this is 1 week ago, this is yesterday, this is today, this is the day after tomorrow. Then the trend is completely wrong. Because if you transfer here, in the actual scale of the time, last week will be somewhere here, perhaps. Yesterday will be somewhere here. Today will be here. The day after tomorrow. So there's a main difference between scattered and line plot. And line plot, of course, the scattered plot, of course, can be used to plot distribution as well. Because it really shows the actual scale of the input variable and also the output. So if let's say your input is not continuous, your interval for the input is not continuous, some of the point will be calculated here, some will be calculated on this side. Then you can show the distribution point as well. You can see that as well. We will look at some example, the actual plot, and then we can help with it. Bubble plot, like we said just now, is pretty much the same like the scatter plot, except that for each of the point, it can carry one additional layer of information. It can be another output, another result, or it can be another input, depending on which information you want to put it in. So the size of the bubble can give that insight as well. But it probably will just give an impression. One is larger than the other. If you want to read the exact value of it, it's not very good. Because how can you tell this? If I ask you these two circles, Are they the same size? Are they one larger than the other? Difficult to tell. Unless at this point, if you just look at this, it probably looks more or less the same. Okay, that's how what we can get out. Area plot. Excuse me. Area plot is basically the same like line plot. Except that area plot, most of the time, someone will stack the line. So, the reason that someone will use an area plot is they want to highlight how big the area actually. That's the only difference. Waterfall. Waterfall basically show progression. Because the way waterfall plot is this category 1 value. This is the second category value. This is the third. So by the end of the third bar here is the sum of them. It's pretty much like this stack plot here, but break it down so that someone can see the category. So the circumstance that we use it can be different, depending again what kind of insight we want to show. If we just want to show there's no progression, we just want to show between different categories, then obviously we wouldn't do it this way. This is, again, because you see from left to right, sort of like time related. So it's a progression. Not sometimes, most of the time, people in finance will use this. The sales this month, the sales next month, third month, something like that. So over 1 year, this is the model, something like that. Pie chart, we went through it shows the proportion. But the rule of thumb is trying to avoid too many slices like the one just now. In fact, there is some who argue that for pie chart, really we only what we really want to show is just one single slice. Actually, the one we want someone to emphasize on. For example, in this case, the blue one, we can pretty much only tell the blue one. The blue one is slightly over 1 quarter. The rest of it, if we want to somehow relate to its value, it's a bit difficult. So usually it's the larger slice or the smaller slice we want to show. Kind of. And if we add additional layer to the pie chart, we get summers. Summers basically means inside here still a pie chart. Actually it's called the pie chart because exactly, but essentially it's a pie chart. In this case, there are 3 key drivers. Let's just put it the input. Under this input here, there are, let's say, 4 things that probably will affect them. And it's relative proportion compared to this. Okay. And then the third layer is, so here actually there are 4 layers of information that we will show up. But use it with caution because the minute that the plot becomes complicated, you have to really highlight what you want to show really clearly. And compared to this, if we really want to show the proportion of it, sometimes this might do a better job. Because from here, you can really tell this is larger, whereas these 2 are more or less the same. Something like that. Again, the information between here and here is exactly the same, but it's just what we want someone to look at. So let's try let's look at a few plot that you guys done before. Then now you tell me whether it's good or bad. Okay, so here are a few plots. I simply extract from your report. Okay, don't mind, please don't mind. Okay. So give your honest opinion. So let's start from, let's say this. So this year, probably some impact category, the environmental impact, over different different resin type. Okay. And then the information from two manufacturers. Everything show in 100%. So for someone look at this, what would be the information you get from here?
Six types of plastics.
There are 6 types of plastic. Okay. And I suppose you can also tell there are 5 environmental impact. But does the bar inside show any information?
Only the relative among 6 plastic types.
The relative among them, right? Into 100%. So in fact, this chart here is too crowded with information. Too many input and the key result is not being highlighted enough. So I suppose this chart here wanted to show how the environmental impact of each resin will be different among them. So if that's the case, the first variable, the variable will be the resin actually, and the result will be the impact category. So in this case, it actually better to plot in for each of them, the 5 plot of them. So if I go back to this, it will be perhaps looking like this one, the first impact category, and then the different bar represent different resin. So then the bar is close to one another. You can see the magnitude is different very clearly as well. Of course, the magnitude of the environmental impact probably is not the same because they are different units. So if you plot everything in one chart, probably some of it is too small to see. So my suggestion for that is actually not to put all together. Because somewhere between this and this, okay, the percentage increase, but then we don't know the actual magnitude. It is suppressed information. So actually, this I would really recommend to put in the percentage. How about this one at the top?
There are 2 inputs.
Which is
One is product mass,
okay.
and another one is not shown here, but it's production size per batch.
Size per batch, which is size of the bubble.
Size of the bubble.
And okay, because here they put the red and this one, they put a label. So probably sort of trying to tell what the chart want to say. But if I remove that away, just looking at bubble itself, what kind of impression do you get?
Very scattered.
Very scattered, correct? Because it's a bit all over the place, right? But it also try to show majority are actually around here. At least the bubble there is larger. And it's more densely distributed towards down there. Up there, yes, there are some scattered up there, but the bubble is pretty small. So in this case, if we don't use the bubble, we don't show this additional layer of information, it will just look like this. You see it's scattered around, but you wouldn't know that it's more densely populated at a certain point. So which is why sometimes having one additional layer of information can help show better. And that is perhaps why they say that okay, the overall average is somewhere here, not in the middle. Because if you imagine that plot is just point, then the average probably will be somewhere in the middle rather than towards the top. And on the left here, I have two sunburst charts. Let's start with this one. It's very crowded yet. A lot of information. A bit too much. But if you don't read, it's probably too small for you to read as well. Especially those out there. But just look at that. What's the first thing you think the chart trying to show you?
Energy has the highest proportion.
The red one.
Yes.
So that's the power of color actually. Striking color always catch attention. So everyone has their color palette for their chart different here. The color will be different, the choice of color will be different. Some favor a more neutral color, like this and that, all very neutral color. So when they are all neutral, the darkness can make a difference, contrast basically. You want high contrast to highlight something. If you are using vibrant color, obviously the one that's more striking, you always catch the attention. And in this case, it's very clear for most like 75%. Even they don't label it, but just looking at this, which is why the largest piece of pie usually is the first one to launch. And in comparison to this, where do you think this chart want you to focus on?
Composition of the product.
Composition of the product. But someone can very easily distracted by this big slice. Even though if you look it closer, because here got more things, right? More information, then the color also more vibrant bit because blue compared to gray. So in this case, I would suggest this one probably can make it more faint. Try to bring the attention away from it. Unless the focus is here. So sometimes we need to show more information. Certain occasion we want that. Most of the time we try not to because when you plot one plot, most of the time in one slide, you'll be discussing on probably one thing, two things at most. You only focus on a certain thing. For this chart here is different because it appears from in the website. So one chart, they have the whole website to describe it. So the application is different. Hence, they need all the information crowded in one single plot. Which someone read the website, then they can come back here and read. But if you are doing a presentation, usually you put one plot, one chart, you discuss about one topic or one hypothesis, let's say. Right? You want someone to focus on that particular thing. So always get the audience attention to that point. And a few more here. Let's start from the one over here. So 3 more or less similar plot. It's a 3 separate plot, basically. Okay. It's a scattered plot. So what do you think that chart is trying to show?
Whether the equation is correct.
Trend. If this plot here, remove the line, would you imagine the data as like going that way? No. Some yes, some no. Like this one very obvious, right? The data is very in a very nice trend going up. But something like this, maybe not so much. It's like going horizontal. So it is a scattered plot, hence it shows distribution still. If let's say you want someone eye to catch that, okay, it's going upward, put a line. Then naturally someone will see, okay, the trend overall going up, but the plot also trying to show that how far the point actually distribute about the line, the trend line that someone wants to show. In another way, how well the equation actually regress the distribution. Obviously, this is very well regressed, hence the R square is very high as well. And that has the worst, 0.772. So it is not that good. But overall, okay, fair enough, the trend still go on. At least it's not like from top, come down. How about this one?
To show the difference
Between?
values between the 3 category.
Between the 3 category, these 3, right?
Yeah.
Obviously, there are 2 different input here, right? We have this, we also have this. Okay. Now, which one should be this and which one should be this? Like, if let's say before this chart is there, which means you probably have, if I, well, we plot this from the table, right? The value, the result always in the table. So we have, let's say, I'll just call it X. The data probably looks like this. So how do we know which one is X1, which one is X2? Where shall we put X1, where shall we put X2?
Depends on what you want to show.
Okay. So if I ask you to put this into the tree like this, obviously only one, right? We're only looking at one example. So this layer would be will be this category or this one.
The side.
Yeah, usually with the side one. That should be the main category. Then inside only the smaller. Usually that's how we arrange it. And only one thing that I will probably be picky a bit on this. All the bar color is too colorful. Then again, it sort of lost the focus. What to look at? Is there any certain component that we want to look at? Because when the color is so striking, I will probably just be, first thing I'll look at is probably the orange bar. Or in fact, in this case, I'm not too sure. Because it depends on what someone want to, how we want to discuss this. Okay, this is 3 different methods, let's say. Okay. If the intention is actually to show for each of these items, the error here is reduced with certain method, then really the big category should be the item. Like the first, let's say I was looking at the orange color, the working fluid. I want to show that from 0.6 rule to weight scale factor to thermodynamic scale factor, the error change. I will actually put the 3 of them under 1, which is I'll go by the component rather than the method as a big category. Whereas if I want to show, like what I want to show to the audience is, as an overall, this method gives smaller error. Then yes, of course, I group all the components together and I separate using method. So same data, depend on what I want the audience to see, I put it differently. So that's the powerful of chart actually, because it's a graphic illustration. For the same reason, if you don't put it correctly, it can be misleading because people don't see the inside much. And the thing is with chart, you may plot it today, think that it's okay. Tomorrow you look at it, probably you feel nonsense. It's always a bit of try and error, unfortunately, with chart. So try a few plot, especially when it comes to chart with so many information. Okay. But one thing for sure, you see all this while the input and output is always fixed. Like none of the chart we change the input output because first of all, we are not in the situation to discuss which input output we should be looking at. That is, from the beginning we should know, okay, we want to show this input and output, then we choose the chart accordingly. And the last one perhaps is for this. So for this chart here, again, what do you see? Like the first impression.
The difference between 2 models. There are 2 models.
Okay. Because one on the left, one on the right.
And then the proportion from for seawall piping increases from 1 megawatt to 2.5 megawatt.
The gray part, the gray part become larger. Even if we don't look at if no one shows the number, at least you can see it usually this become larger. Yep, I think graphically, this chart catch the audience attention very clearly, very well. Especially the line helps a lot. If we remove this line, it takes a bit of time to digest it. Eventually you still see, but that's what we don't want. We want something that can guide people, okay, from here, they know for sure it's going to here. So sometime after we plot certain chart, we can always add additional things to help guide the audience to look at it. Same for this line in the middle here. Just because of this line, it becomes very clear that here has nothing to do with here. Otherwise, if without here, you may just think that, okay, this is a wonderful, it shows progress. So come to here, then this come down. Then it can be misleading. Because of this one additional line, it's sort of split between the two of them already. So putting a bit of help to the audience, that's always helpful. The only thing here on this chart, again still, is the color of this. This is the highlight. It should be the one that actually with the stronger color. But at least the line is in red, so it overpowered this blue and this, I would have to say. And there's absolutely nothing wrong to put description along the chart, just to help, even in report or in presentation. It always helps to have the description right next to what you want to show. Right. So with that, I think we come to the end of this training here. Okay. So I'll wrap it up with three conclusions, reflecting the objective that we see at the beginning. Right. So the first thing that we touch on is on the hypothesis-driven approach on how to solve pretty much any problem. And really the benefit of doing that is once we map out the entire problem, we structure the entire problem, then it can become clearer to know which problem that we're actually solving, which hypothesis that we're actually testing. Again, simple problem, if let's say just one line, if you remember the problem acute solution, just one line, I think everyone can imagine it in their mind. But if let's say there are multiple lines, then things may get left out very, very easily. And not to mention that if, let's say you can structure the whole thing out, it will be easier to explain to someone as well, graphically. And second is on the content organization. Okay. Again, the principle that we went through is try to separate the content, okay, as independent as possible. But at the same time, when we put them all together, it still becomes the whole also. I think we need that found. Again, it's really mainly to achieve clarity and congruence. Okay. And it has a lot. The 1 and 2 is pretty much kind of hand in hand, because it will basically decide how you define your key driver. And later on, because if you remember the hypothesis-driven approach, later on when you show the result, in data analysis, it's basically the same key driver that you'll be following, and hence you'll be showing your result, present your result in that way. And lastly is the result presentation. Okay. So really the main goal for result presentation is being effective, so that the audience can gain the insight in the first glance without having to think much. Just looking at the chart, they know what to catch and what you're trying to say. I think that would be the ultimate aim to achieve. in other words, we can say it's more in a visually compelling manner. Okay, right. So that is pretty much all for today's training. So thank you very much for attending. And before I dismiss you, I'll need your help to fill out the feedback form. So that'll be all for today. Thank you very much. Thanks.